I'm Dan from Chaincase, bringing you PayJoin. Chaincase is a privacy-preserving mobile wallet that stops spies from tracking your financial activity, and PayJoin is a new component of that. PayJoin solves the problem where everyone knows your identity and can track you across the network. Right now, when you use Bitcoin, anyone who can see your face when they scan your QR code knows who you are. Your network knows your IP address, and most wallets can cluster all of your Bitcoin history together unless they're using something like Neutrino Private Sync or they let you use your own full node. So we're going to go through what that means, what that analysis actually looks like, what the spies do, and how to solve that. So we're going to get into the nitty gritty here. On the right, what are these bubbles I'm showing you? That is a Bitcoin transaction. On the left of the arrow, we have 3 pieces of Bitcoin called transaction outputs. And on the right, we have new transaction outputs that are created as part of this transaction. Bitcoin isn't kept in accounts, it's kept as actual pieces, discrete amounts, and the amounts are denoted here by the size of the bubble. So what analysis does right now is make some guesses called heuristics about where the inputs to a transaction came from, and then they can track the activity assuming their guesses are correct. So one of these guesses right now is called common input ownership heuristic. And common input ownership heuristic is where all 3 on the left are owned by red. They assume that's one person. And they assume that these inputs came together to create enough to pay blue, and then whatever was left over goes back to red as change. Now, if they know you are red, they know your IP address, they can follow you all across the chain. So that's what we're trying to break. And typically, in the past, historically, we'd do this with CoinJoin, where multiple people would come together, 4 in this case, blue, green, red, and yellow, and they'd create a transaction that results in equal output denominations. Why do they do that? Because the equal output denominations don't have a link to the original identity. Because they're the same amount, they can't be solved like this past transaction could, where it's like a Sudoku puzzle. Whoever adds up, basically, whoever's cluster adds together must be the same person, which they can still do for the change. So they still know that the 2 red inputs on the left must have a change output on the right. That's red, and yellow still has a change, and blue still has a change. But they no longer can track the rainbow-colored equal outputs. So what about PayJoin? Where am I going with this? Well, PayJoin breaks heuristic analysis in a different way. And to show you that, let's go through an example. I'm showing you here 3 transactions. On the top, a CoinJoin we just went through. On the bottom, a withdrawal from an exchange. And on the right, a merge where gray and yellow both fund a transaction to create a big output. Now, historically, like we showed before, heuristic analysis is going to say that merged inputs to a merged transaction are going to belong to the same person. So the withdrawal was done by yellow, and that history must also be the same person, yellow, from the CoinJoin. But with PayJoin, we can prove them wrong. We can make that heuristic false. So what does that mean? By breaking this heuristic, anyone who has a transaction that looks like this merge, this PayJoin, either of these, it could be either of these realities. So it provides them privacy. It provides some indistinguishability for them. And I'll show you how this looks from a UX perspective. So we're going to demo what the PayJoin looks like with the familiar UX. On the left, we've got my actual device on my desk. That's Alice. On the right, we've got a simulator. That's Bob. Both wallets already have Bitcoin. So just like any other payment, we're going to create an invoice. In Chaincase, you have to label your payments. So that came from Alice. And we're going to turn on the hot wallet PayJoin server so that Bob can collaborate on this transaction. It's an interactive protocol, like I said. You can see in this invoice address here that there's actually a HTTP server. That server is a Tor hidden service so that Alice can connect directly to Bob here. We're going to pick an output to send, the whole thing. Verify that it's Bob. And now what's going to happen is Alice sends a proposal to Bob with Alice's input. Bob's going to add more Bitcoin to the input, send it back to Alice. And when Alice approves and says it looks okay to her, she broadcasts it to the transaction to the Bitcoin ledger. We get a transaction ID there. It should have shown up for Bob. There it is. It's pending. You can see the ... Let's see what this looks like on chain now. So this is a typical transaction. This is what most transactions on Bitcoin look like. We have just some input, an output that's very large compared to the size of the change. So the change is easily identifiable here. But we're going to look at what we just created, which is what looks like a self-transfer. It's a join. We've got the Alice coin and the Bob coin merged, but we know that it's not. We know that Alice actually combined her coin with Bob in order to pay Bob this amount. So it really screws up the chain analysis. So more about the Chaincase project real quick. I'm Dan Gould. I've been working on Bitcoin privacy for 4 years, starting with Tumblebit, into Wasabi, now on Chaincase. This app is available for beta with the regular CoinJoin feature, Neutrino and Tor. Andrew Camilleri has also contributed to this. He wrote the most widely used PayJoin library to standardize this across multiple wallets. Armin Saburi's at Casa doing full stack engineering. He was on the hackathon team that built this PayJoin implementation. Johns Beharry and Ed Pratt both are supported by Square Crypto, part of the Bitcoin design community. Johns was on the MIT Hackathon team, as well as my teammate Ron Stoner, who's the head of security at Casa. If you want to learn more, go to Chaincase app, check out our GitHub, join the Telegram group for support. I got to give credit to Nicolas Doye for the slides. He did a great PayJoin presentation before. And then if you want to contact me, I'm happy to help too. Thanks for watching.